welcome. Today let's try to solve another Leetcode problem, 877 still game. And the description is easy to understand. We just have a pile of stills. And there are two people, Alice and Bob. So Alice will take the still for the first time, and then Bob will take the still. After that, Alice will take another still and Bob will continue. So we just need to calculate if Alice can win. So how Alice can win if the values of the still Alice taken is more than the values of still Bob taken. So for example, Alice take 5, maybe Bob take 5. For the next time, Alice take 4 and Bob takes 3. So Alice can always win. Yeah, if Alice choose optimally and Bob also choose optimally. Yeah, but Alice can always win. Actually, for this problem, yeah, like the game theory, who start first, who will always win. So Alice will always win. But I'm going to use game theory to analyze the problem. Basically, it is a dynamic programming. Now let me go to the whiteboard to explain the problem. After that, I go to the code editor to finish the coding. So we are having an array of stills. We have 5, 3, 4, and 5. So basically for the search, for Alice, I'm going to start from the 0 index or the index 3 because I can only take the first still or the last still. So for Alice, I can choose 5 and another 5. Yeah, this 5 or that 5. But for the Bob, I use a gray color to represent Bob. Yeah, so if Alice takes the index 0, so this is the index 0, Alice get a 5. And Bob can only take the index 1 and or 3. If Bob takes 1, it left behind is 3. If Bob takes 3, so yeah, if Bob takes index 1, so Bob's value is 3. If Bob takes index 3, so Bob's value is 5. Yeah, because this is not a greedy idea. So this is by choosing all combinations, but I use a memory to remember which value I take at the different pointers of L pointer and R pointer. Yeah. But for here, let's continue. If Bob takes this first index, it means Bob takes a value of 3. So what left behind is index 2 and 3. So Alice can either take index 2 with a value of 4, or Alice can take an index 3 with a value of 5. Yeah. Now what left behind is only 3. If Alice takes 2, so Bob can only take index 3 with a value of 5. Or if Alice takes index 3, so Bob can only take a 4. Yeah, so these are all the combinations. So in total, Alice can get a 5 plus 4, it is a 9. Yeah, or Alice can get a 5 plus 5, it is 10. Yeah, so this is what the Alice can get. Yeah, yeah. So like these combinations for the let's check. I think they choose the stills optimally. Yeah, if they choose it optimally, yeah, let's check the problem. So Alice Bob take turns, with Alice starting first. Each turn, a place takes the entire pile of stills, either from the beginning or the end. This continues until there are no more piles left, at which point the person with the most still wins. Yeah. Yeah, so this is all the combinations. So inside all the combinations, so Alice will always win because, for example, this is a 10 or this is 9. But for the Bob, so 3 plus 5, it is 8. And for this one, 5 plus 4, it is 9. Yeah, so these are all the combinations. But we want to choose the maximum value Alice can get. Yeah, but normally for the still game, I think it should be chosen optimally. Alice Bob plays a game. There are even number piles. Yeah, to get the most steals. So Alice was to win. Bob also was to win. So we need to change a little bit about this drawing. So we have a steal of 5, 3, 4, and 5. Yeah. And from here, it's all the combinations. But for all the combinations, Alice can win. So we need to choose the maximum result Alice can get. Yeah, but for example, if Alice chooses the 5 first, if Alice chooses a 5 first, this index 0 first one, so the Bob will choose a 5. Yeah, because 5 is the maximum. So Bob gonna choose a 5. So for the next time, Alice gonna choose a 4. And Bob can only choose a 3. Yeah, but this is not the greedy idea, but this is only the greedy idea. It is not, it doesn't mean for each time Alice will always choose the maximum steal, because this cannot be the final result. Yeah, because this is not the greedy idea. It has to be all the combinations. And for this branch, there are also all the combinations. But finally, we just need to return the maximum value of the steals Alice can get. Yeah, if Alice get a 5, so Bob can only choose 3 and 5. After that, Alice can choose 4 and 5, and Bob can only choose what's left behind. Yeah, and this is just one combination. Basically, we need to choose all combinations. We are not calculating the minimum value Alice can get. So we are calculating the maximum value Alice can get. So if the maximum value is more than sum of all the steals divided by 2, it means Alice can win. It doesn't mean Alice wins every time. It means Alice can choose optimally to win. Maybe one strategy, yeah, maybe one pass or 2 pass, but can win. It doesn't mean every time Alice can win. Yeah, because we just needed to check if Alice can win. Yeah. Now let's try to solve this game theory problem into a DFS. So for the DFS, basically, I'm gonna define the DFS function. So inside, I'm gonna choose 2 pointers, L pointer and R pointer, as my positions of the steals. So I'm gonna have a pass first. After that, I'm gonna call the DFS function. It's gonna be 0 index to length of the piles minus 1. This is the 2 positions of the steals. I can check. So if this L index is normally always less than and equal to R, if L is more than R, I'm gonna have a 0. It means I didn't get any steals. So for this function, actually, I always calculate what is the maximum steals Alice can get. So I will ignore Bob. But in the function, I'm also gonna consider for each time, which time is for Bob, which time Alice is taking. Yeah. So I'm gonna prepare a variable Alice. Yeah. So the Alice means Alice will take the steals. So how should I check at which time Alice will take the steals? We know that for the first time Alice will take a steal, and for the second time Bob will take a steal. You can use some like sign to represent. Yeah, like the first time go to the loop sign gonna be false. For the next time, maybe this sign gonna be true. Yeah, so this is one strategy. Yeah, because you will shift this sign by true or false. Maybe for the first time the sign, this variable is true, and then for the next coding the sign gonna be a false. Yeah, I mean here you can put it inside a variable like true or false. You just wanna coding this variable. Yeah, or I can also prepare to give it Alice to make it a true. Yeah, let me first prepare the first solution, because for this side, I just come to this idea immediately when I'm talking about the solutions. So let's just first finish our function first. Yeah, and then I'm gonna use assign, maybe try to check if it works. So how should I check Alice? So we know that for the first time, Alice must take. Yeah, and there are also even numbers of piles. So I can use the R pointer minus this L pointer to check which time Alice take. So if this R minus L divided by 2, it means Alice will take. So it will be a true if R minus L modulo 2 equals to 1. Otherwise, so Alice will be false. So this means Alice will not take the steal. Let's just check. From the beginning, this is 0, this is 3. 3 minus 0, 3 modulo 2, it is 1. So if the modular result is an odd number, it means Alice will take the steal. Otherwise, Bob will take the steal. So this Alice just means at which time Alice takes the steal. Now, I'm going to prepare a variable left and right. So the left should equal to the piles L. So L index. Yeah, so if Alice. So I'm always calculating Alice, else it will be Bob. So Bob will take a. So yeah, because I'm only calculating the Alice, how many steals. So for Alice, if for the first time, for example, if Alice takes the left, it will be a piles left. Otherwise, it will be a right. Yeah, right will be a piles R if Alice, else it's gonna be a 0. So what did I mean by that? So left means at the left side of the piles. So right means at the right side of the piles. Yeah. So for the first time, if this is modulo by 2 equals to 1, it is an odd number. It means Alice will take. So for the first time when I code in the function, so Alice will choose either this number 5 or this right number from the right. So this 5. Yeah. But for the second time when I'm coding the DFS, it means for the Bob will take the what's the left. If Alice takes this 5, so Bob can choose 3 or 5. Yeah, this 3 or this 5. But here inside, actually, I don't care how many steals Bob can take. I only take care of Alice. So for the next time, I only let it becomes, for example, Alice takes a 5. Maybe Bob takes 3. I only let it become 4 and 5. Yeah, but I didn't add any value because for the next time, the value becomes 0. Only the DFS makes the range smaller, but I didn't get any result. Because Bob takes the steals, I don't care. Only for Alice, so for the next time, if 4 and 5 left behind, and this R minus L modulo 2, it means Alice will take. Yeah, if Alice can take, I will get a value, left or right. Yeah. But even for Alice, I will get the maximum of the result. So it will be DFS. So if I take the left side, it's going to be L plus 1R, and then I'm going to plus this left. So this is the value. Or Alice can take the right side, it's going to be L to R minus 1 and plus right. Yeah. So this means for the when Alice take, yeah, when Alice take, I'm gonna have a value left or right. But for the next time when Bob take, the left and right becomes 0. So I only make the range smaller. I only shift the pointers, L pointer and R pointer. I didn't change the value. Yeah. Yeah, because I'm calculating the result for the Alice. But after that, I'm gonna take the result. Yeah. Now let me run it to check if it works. Let's see if there's something wrong. Yeah, I got a result of 10. Actually, it should be true. Yeah. Yeah, I think they correct the testing cases. Normally 10 is also true, but they make a Boolean value. So actually, as I explained before, we have to check if this is more than sum of steals divided by 2. Because the steals can never be an even number. It is always be an odd number. So we have to check the result of the steals for Alice taken if it is more than the sum of the steals divided by 2. Let me run again to check if it works. It's piles, not steal. Yeah. Now let me run it to check. As you can see, it works. Now let me submit it. I believe I cannot pass. Why? Because I didn't use memorization. Yeah, if I didn't use memorization, it is 2 to the power of n. It's gonna be a very large number. We cannot pass. 2 to the power of 5 is 500. It's a very large number. So this is why we should use memorization. We just need to add a cache. Now let me submit it again to check. After that, I'll analyze the time complexity. Yeah, as you can see, it passed. And it's not so fast because we didn't use actual DP. We just simulated the DP. We used the DFS. Yeah, basically for coding of the functions, it really takes the time. It's not like taking the values from the index. It's not like tabulation of DP. Yeah, but we can still pass after using the cache. Now let me analyze the time complexity. For the time complexity, because this L and R positions has already been recorded in the cache, so it didn't take more actual time. So it is n square. So n is the length of the piles. So 500 square is not a very big number. So it means why it can pass. Or we can also simulate the function use another way. Yeah, let me. So up to now, I used this Alice variable to check which time Alice take the steals. Or we can also use a sign inside. So we can also prepare another variable. Maybe, yeah, for the first time Alice will take, we can put a true inside. Yeah, here I'm gonna give Alice. Normally I don't want to give a capital. I want to, yeah, let me make a sign. Yeah, maybe I make a sign. So this is just a sign means Alice will take. Yeah. So I don't need this one because sometimes you can't think about this R minus L modulo 2. Sometimes you don't care about it. Why you can think about this formula? This is difficult to think. Maybe you can think about this way. Yeah. For the first time, you can put a sign inside your function. And for the first time, it's gonna be true. It means Alice will take. Yeah. So here, left is sign, and the right also is sign. Yeah. But after that, you're gonna update this value. It's gonna be a false. Let me check. It's not false. It's gonna be not sign. Yeah. If you give a false, what you should do for the next time? It should be not sign. Let me put a not sign, and here also not sign. Yeah, I mean for the next time it is false, but when you put a false inside, for the next time it's still going to be a false. So you need to toggle this is true or false. So you should give a not sign. Yeah. Yeah, basically I think it should be okay, but let's check if it works. Missing one variable. I did something wrong. Yeah, I did something wrong. Let me put it in one line just to check if I did something wrong from here. This is not signed. Yeah, here should be not signed or not Alice. Yeah, now let me run it to check. Yeah, as you can see, it works. Maybe this is the basic idea most of the people can think about this way to solve the problem, because sometimes we cannot think about the index R minus index L modulo 2 to check it is Alice or Bob. But for this one, true or false, you give a sign and not sign. Yeah, it is easier to think about it. Yeah, basically this is the entire code for today. Thank you for watching.